Right, so number 6 is the easiest of the three. A particle P moves on the x-axis at time t seconds. The value of the velocity is v meter per second in the direction of x, which is increasing. So we have an expression for the velocity, which is 8t minus 2t squared. When t is equal to 0, P is at the origin. So you are starting at the origin. We need to find the time taken for the particle to come to instantaneous rest. So whenever we're talking about instantaneous rest, we know velocity should be equal to 0. That means basically I'm asking myself, when does v become 0? So you could change this into a quadratic equation with 8t minus 2t squared. If you plug this into your calculator, you can get two values for t. One of them is 0 and the other one would be 4. So those are the... Now, why does those answer make sense? Because t equals 0, you're only starting and you know you're starting from rest. So that sounds about right. Because at your initial position or at the beginning of time, you are at rest. That is why you get the value t equals 0. And then when is the next instance when you become 0 or when you become rest? That is when t is equal to 4. So the time taken for the particle to come to instantaneous rest would be 4 seconds. For part B of the question, we need to find the greatest speed of the particle. So drawing a graph always helps. So this is a negative quadratic, so you have to pay attention to detail here. It is a negative quadratic, which means we're doing an upside down U this time. And we know the roots. The roots are 0 and 4, which means the quadratic should go something like this. So you have your first root here and your second root here. So we have to figure out the greatest speed. So all you have to do is press the equals button 2 times on your calculator. When you press it the first time, a number 2 will appear. When you press it the second time, what is the second number that comes up? 8? 8 appears. So the first number is telling you the x-coordinate of the maximum point is 2. The second number is telling you the y-coordinate of the maximum of the maximum point is 8. That means your maximum happens at 2 and the maximum speed that you're achieving is 8. That is what 2, 8 kind of says. So the maximum value happens at when you're at 2 seconds. And the greatest speed that you have achieved is 8 meter per second. So the answer for part B would be 8 meter per second. Yes?
So, but you know how it says minus 2t squared? So it'll be upside down, no? I mean...
Yeah, it's upside down.
Yeah, because when you have a negative quadratic, that would be upside down, yeah. Or the smile, the sad face, if you think about it. So that is your upside. Right. Now this one is slightly trickier but if you read the question, if you kind of get that key point, this might be easy. At time t is equal to 0, let's draw a picture. At time t is equal to 0, anybody wants to copy any of this? Or can I move on? At time t is equal to 0, a particle moves in a straight line, a straight horizontal line from a point O. So it is moving in a straight line. Then returns to the starting point. So you're coming back to the starting point. The distance s meters from the point O at time t seconds is given by. So this is the distance from the point O. So that means when you plug in t as 0, what will be s equal to? When t equals 0, s is equal to 0. Does that kind of sound right? Yes, because what is your distance from 0 when t is equal to 0? 0. You are at the origin, so you're not moving anywhere. If you put when t is equal to 1, what do we get? 3 minus 1, which is 2. So that means when you are 1 second away, that means when t is equal to 1, you are 2 meters away from your starting point. Try when t is equal to 2. What happens now? That would be 12. 12 minus 8, which is 4 meters. So when t is equal to 2, you are 4 meters away from the origin. But see what happens when you do t is equal to 3. When t is equal to 3, what do you get? 0. Why do you think we got 0 now? Because in the first 2 seconds, it was moving forwards, and in between the second and the third second, it came back. So when you plug in t as 0, you can kind of see that it comes back to its original position. That is why you get t as 0. Okay, so you don't have to do any of this. Once I was just trying to explain what is happening there. So all you have to remember is, if something comes back to its initial position, s would be equal to 0. So all I am looking for now is, when does 3t squared minus 2 cubed become equal to 0? So that would mean t is either equal to 0, or you have 3t minus 1. No, how would I factorize this? This would be t squared times 3 minus t. So that means either t is equal to 0 or t is equal to 3. So you have 2 places where the object remains at origin. Once when it was moving forwards, and during the third second when it actually came back to the original position. So this was when t is equal to 3. Does this kind of make sense? Yes. Right, number 8. Let's see. Looks pretty much okay. You didn't do it. Okay. Yeah, so you can try this.